Good morning, students. Today we are going to do an extension on from the unit circle from last class. First thing before I start that and have you write down these notes, a couple reminders. Your geometry review packet number 1 is due Thursday or Friday, whichever day you have class. Make sure you show your work on each problem. If I don't see work, I only see answers, no credit. That means you're just copying off somebody. I saw that on some of your unit circle assignments you just turned in the sub yesterday. So make sure you follow the examples I show you here, drawing the correct triangles in the correct quadrants with the correct side lengths and correct signs on each number that some of you were not doing in following the examples I gave you for the unit circle assignment. Reminder also, those that need to retest, that will be done Thursday or Friday in class. So those who are retesting, especially should watch this video, take the notes off this video, so you can just focus on taking your retest in class, and then once you finish that, then go ahead and work on this assignment, but already have your notes done ahead of time and watch this, since you'll miss it doing the retest in class. All right, let's go ahead and get started. Go ahead and write down your student outcome here and your SOHCAHTOA information that you have here. This is all review from what we've done here in this quarter and also at the end of second quarter, right before the first semester final. Pause the recording here until you have these notes taken down and then go ahead and continue. All right, so let's go right into examples here. It says find the missing trig function. Theta is the reference angle and the hypotenuse is always positive. Remember that the hypotenuse is always positive. Okay, whether one of these signs is negative or not, that sign must be moved up to the numerator. If this is the hypotenuse, it's a sine here. We know sine is opposite or hypotenuse, so the denominator would be the hypotenuse. If they put a negative down here, it would have to get moved up here because the hypotenuse is always positive. We'll see that in example 4, where we have one of these as negative. Okay, so that's just another reminder as well. All right, so it says if an angle is an acute angle right triangle, we know acute is between 0 and 90 degrees, so we draw a triangle in quadrant 1. So draw yourself your XY coordinate plane. Draw yourself a triangle in quadrant 1. Remember from last class, the unit circles is our quadrant 1 triangle. Go ahead and put in your right angle symbol. Some of you need to work on drawing actual right triangles. Some are just drawing sloppy triangles in your unit circle one. It's not good enough. You need to draw it at least so it looks somewhat like a 90-degree angle, and then put your 90-degree angle symbol, right angle symbol on there. All right, theta we know is always between this terminal side and the x-axis every time, never between the terminal side and the y-axis. Okay, this terminal side obviously is called the hypotenuse in your right triangle, so you can also think between the hypotenuse and the x-axis. Now the difference today is that our hypotenuse, unlike the unit circle, in the unit circle, remember our hypotenuse right here was always 1. For unit circles, the unit mean was 1. So we're not doing unit circle triangles, we're just doing quadrant triangles in this case in today's lesson. Okay, but very similar to the last one. So we go ahead and put our theta in our reference angle right there between the hypotenuse and the x-axis, or terminal side and the x-axis. Okay, and it tells me sine of theta, the sine of this angle, is 4/5. We know sine is opposite of our hypotenuse. If you want to go ahead and write that in there and put it right next to the letters themselves, you can, and that's fine. Those that really have it memorized already don't have to, but if you're not confident in that and you want to have it to check that you've plugged the numbers in the right spot, go ahead and write that. So we know the opposite side across from theta is 4, so put in your 4 there, and the hypotenuse is 5. Now, this whole assignment can be done very quickly, again, because you've drawn your triangles. You learned how to do that last class, and all of these lengths I'm having here are always going to be Pythagorean triples. You know how much I've pounded home Pythagorean triples throughout the year, and I expect you to have it memorized going to Algebra 2. Save yourself time in Algebra 2, SATs. You do it again in pre-calculus and calculus. So get those memorized, especially those are going to higher math for the next 2 years, 3 years after this. All right, so knowing that, you should know that this is 3 right here. If not, you'll have to use Pythagorean theorem. A squared plus b squared equals c squared, and solve for this side, and you'll get a 3 there. Remember, when you solve your Pythagorean theorem, you normally would have you'd have a positive, negative 3, but we only take the positive answer because distances can only be positive. Okay, so we're not using the negative one. All right, so here's our triangle drawn in quadrant 1. Remember, any point in quadrant 1, x is positive and y is positive. So both those are positive. Remember, we had already taken notes on this last class with our unit circle trig. You already got those notes. If you need to write it again to remind yourself that x and y both are positive, you can put that up there for quadrant 1. So our quadrant 1 triangle is correctly drawn. Now we go ahead and just answer the question. Tangent, we know, is opposite over hypotenuse, as we already have, I'm sorry, opposite over adjacent, as we already have written right up here. And now you can just fill that in with your answer. Opposite 4 over adjacent 3. Okay, if you need to put on your O for opposite side and A for adjacent side, remember the first thing I taught you when I first learned this is to identify your hypotenuse first, because the hypotenuse never changes. And that way you don't get confused which side of these two is the adjacent. If you put that hypotenuse first, then the only two sides you have left are opposite and adjacent. Okay, so if you still don't have that down and you need to remind yourself of doing that, then go ahead and do that. 4/3 is reduced, so we're done right there. There's our answer. If it's simplified, we would need to simplify it, but it does not. Okay, there's example 1. Example 2 now. It says the same thing in the beginning to begin with. It's a acute angle, so therefore we know it's quadrant 1. So draw yourself a quadrant 1 triangle. Draw your XY coordinate plane here. Draw yourself a triangle in quadrant 1. Go ahead and put in your right angle symbol. Put in your theta, always again between the terminal side and the x-axis. Terminal side, x-axis. Okay, and now we go ahead and fill in our given information. So the cosine of theta, this angle, is 12/13. Remember, cosine, as we have written up here, is adjacent over hypotenuse. And we just fill these in here. Adjacent and hypotenuse. So adjacent, 12. Remember, adjacent means next to. And hypotenuse, 13. Hypotenuse is always across from the right angle symbol. Okay, it's always the longest side in your triangle. All right, and now again, we should recognize this as a Pythagorean triple. We should recognize a 5, 12, 13 Pythagorean triple. Again, if you don't have those memorized, you'll have to use Pythagorean theorem. A squared plus b squared equals c squared, and solve for your missing side length. A or b, doesn't matter which one you call those, and you'll get 5. Okay, and again, it's quadrant 1, so both of these are positive. You don't have to write this out each time. Okay, I expect you to know that you've been plotting points since middle school. Okay, but if you're not confident, you still don't have that down, then you might need to do that. Make sure you get your x and y signs correct. All right, so we have this drawn correctly, and now we just go ahead and answer our trig question right here. What is the cotangent? Well, we already have written down our notes. Cotangent is adjacent over opposite. So what is the adjacent? Next to theta is 12. And what is the opposite across from theta? 5. And that is simplified. So our answer is 12/5. Okay. If it's simplified, we would simplify it. All right, example 3. So if theta is in quadrant 4, and the sine of theta is negative 15/17, so it tells me what quadrant to draw my triangle in. Quadrant 4 triangle. Draw yourself your right angle symbol. Put in your reference angle, theta. Okay. And it tells me what numbers to plug in on 2 of the 3 sides. Remember, hypotenuse is always positive. So even if that negative was down here instead, I would need to move it up to the numerator. Sine is opposite over hypotenuse. The hypotenuse must always be positive. So we have our 17 there. And sine, remember, is opposite over hypotenuse. So the opposite side is negative 15. Okay, and again, you should recognize this as a Pythagorean triple. 8, 15, 17. And now, once I've done that, I need to ask myself, what are my signs for quadrant 4? If I was to plot that point right there, what are my signs? Be positive for the x and negative for the y. Well, this already is set up as positive for the x and negative for the y, so I do not have to switch any of these signs or add anything on to a sign here. Okay, so we've got our correct side lengths for our quadrant 4 triangle, and now we go ahead and answer the question. Cotangent. Cotangent, we just asked that one up here as well. Answer that one. Cotangent is adjacent over opposite. And the adjacent side, again, if you have to name it, name the hypotenuse first. If you don't have this down, the adjacent opposite, should be across from, so that should be easy. That's O over there, and therefore by process of elimination, that is my adjacent, meaning next to. So if you have to do that, you can go ahead and do that. But hopefully by now, most of you already have it down where you know that. I've done it so many times throughout this year here. Okay, and adjacent over opposite right there. 8 over negative 15. 8 over negative 15. That does not simplify, so we are done right there. 8 over negative 15. You can also write it as negative 15 over 8. In an answer key, they would always put the negative sign in the numerator. That does not mean that 15 is necessarily negative. It is in this particular case, but the 8 could have been negative if this was an 8 here, now it's 15 there, it'd be negative 8, but it's still right as negative 8 15ths. In the answer key, they always like to put the negative with the numerator, but they're the same thing. So if you wrote 8 over negative 15 or negative 15, oh, sorry, 8 over negative 15 or negative 8 over 15. Okay, those are the same thing. Okay, just the negative happens to be associated with this. Does not mean that this is a negative 8. It's not. It's a positive 8. Just in most answer keys, they'll put the negative with the numerator, positive with the denominator. Okay, but I'll take either answer. So you can have either that, or as we already have written over here, 8 over negative 15. Either answer is correct. Okay, last example. It says if theta is in quadrant 2. So again, they tell me what quadrant to draw it in. So I draw myself an XY coordinate plane, draw myself a quadrant 2 triangle, draw myself a right angle symbol, bring in my reference angle. Remember, reference angle is always between the hypotenuse or the terminal side and the x-axis. Okay, they tell me what 2 to put in here. Remember, cosine is adjacent over hypotenuse. Hypotenuse must always be positive, so that has to be positive 25. And therefore, my adjacent side must be negative 24. And again, you should recognize this as a Pythagorean triple: 7, 24, 25. Again, otherwise you have to use Pythagorean theorem, solve for this missing side here. Get your 7. Quadrant 2, we should know that when I plot a point in quadrant 2, it's negative, comma, positive. Okay, if you have to write that in there to remind yourself, if you've been blowing on the signs, if you messed up your signs in your unit circle one, you might want to put these signs in here. So check, do I have x negative? Yes. Do I have y positive? Yes. Okay, hypotenuse always positive. That way I can check and make sure I have the right side lengths to put in here so I can correctly calculate my answer. It's asking me to find tangent. We know tangent is opposite over adjacent. So the opposite of theta is 7 over the adjacent, negative 24. 7 over negative 24. Again, most answer keys will put the negative in the numerator. So if you want, you can do that. Negative 7 over 24. Both those answers are correct. That concludes this lesson. Let me just do a quick few reminders. The biggest errors that students make, they will either draw the triangles in the wrong quadrant because they aren't drawing an XY coordinate plane first to make sure their triangle is in the right quadrant. They're just trying to draw the triangle itself. So on the unit circle, I said several people, if it's in quadrant 2, you drew a quadrant 1 triangle. You drew it like this. That's a quadrant 1 triangle. It needs to be in quadrant 2. So if you're doing that, you need to draw your XY coordinate plane to make sure you're drawing a quadrant 2 triangle. Next thing, you need to make sure the biggest error is that people don't or forget to put the correct signs on these two sides. X has to be negative if it's in quadrant 2, Y has to be positive. If it's in quadrant 4 up here, obviously X is positive and Y is negative. So again, if you're having trouble with that, I suggest you write out those signs right there at that point so you have a check, something to check it. Quadrant 1, we know both X and Y are positive, and the only one we haven't drawn, for example, would be in quadrant 3. So quadrant 3 would be looking like this, and both signs in quadrant 3 are negative and negative. So you want to make sure both the X and the Y in your quadrant 3 was a negative, and of course, your hypotenuse or your terminal side is always positive. And don't forget the reference angle is always between the terminal side and the x-axis, or you can call it the hypotenuse and the x-axis every time. Theta is never going to be up here, okay, in these problems. It's always between the terminal side and the x-axis. All right, that concludes our lesson, and now you may work on the assignment.